Okay, Mason, you're good to start on number 1.
Okay, so we're good to start?
Mm-hmm.
All righty. Oh, whoops. Okay, I got it. Get out of it. All right, here we go. Okay, so for number 1, as we're going through, it talks about propose the null hypothesis for the test. So if you look at the data that we observe, how there's 562 green cattle-thons or constructed pods, or however you say that, you can kind of come to the conclusion that the green cattle-thons and the constructed pods are the dominant, and that the yellow cattle-dons and the inflated pods are the recessive ones. And so that's part of our null hypothesis, and that it will follow Mendelian inheritance. So as we go and we calculate the inheritance, if you look at it, we did a cross here, and then we went and we pretty much found the likelihood of getting, for example, green constricted, and we went 3/4 times 3/4, which equals 9/16, and then we found the total amount of the observed came out to be 1,000, was it 126 or something like that?
Mm-hmm.
And so from there, we take 9/16 and we times it by 1,126, and we get our estimated amount. And we do that for all of them. And so then the green inflated, which is 3/16, we times that by 1,126. And all of them are listed there. And we come out with the values of the estimated. And then we go and we plug that into our chi-square formula down there. And so what we do is we go and we take the observed amount minus our estimated amount, and then we square it, and then we divide that by the estimated amount again, and we do that one for each one of the possible phenotypes that are available. And so there's one for the green constricted, another for the green inflated, one for the yellow constricted, and one for the yellow inflated. And then we found out what those values were, added them all together, and we came out with a value of 44.11. And so that is how much we got. So that's for B. And then for C, to interpret the results, if we look at it, that's a very large number. And so if you go back to the shaded reason for our p-value is less than or greater than 0.05, we found that it was less than 0.05, which means that we reject our null hypothesis and assume that it does not follow an autosomal Mendelian style inheritance, and it might be something like X-linked inheritance. Okay. That's
Okay.
it. 1.
Awesome. And then for number 2, let me just pull up the problems so I can read them at the same time. So for number 2, we were looking at the mice at the trait where they had head tremors of the Shaker gene, and then coat pigmentation. So for A, based on what we have learned in class, what inheritance pattern best describes the coat pigmentation trait in mice? I said codominance because they both, or the heterozygote has both black and white spots, so they're both present. Because incomplete dominance would be where there was something like they were gray, in between. But since they were both present, I said codominance. And then for B, determine the genotypes and phenotypes of the F1 offspring. So I have here for B, trait 1, the Shakers. So X plus is the Shaker gene, X with nothing there is normal, and then Y. And then trait 2, the coat color, black, white, and then black and white. And then for this cross, because these were the parents, the children, the genotypes and phenotypes, there would be 50% normal females and 50% normal males. And these would be their genotypes. And then for C, what did you ask? Oh, perform the chi-square analysis. So basically, I did what Mason just explained. I found for each of the different phenotypes, which we had 6, normal black, normal black and white, normal white, and then shaker black and white, and then shaker white. And I had crossed the 2 genotypes that we just got from the last cross, and I found their probabilities. So it was 3/16, 6/16, 3/16, and then 1/16, 2/16, and 1/16. And I multiplied it by the total number of progeny, which was 26. And I got the values 5, 9, 5, 2, 3, and 2. And I used the same formula as described above. I won't describe it again, so to avoid redundancy, but I ended up getting 3.27. And because 3.27 for D, because 3.27 is less than the value on the slide that we use for 5 degrees freedom and P equaling 0.05, which was the value of 11.070, we failed to reject the null hypothesis, meaning that the cross accurately represented the shaker gene being X-linked and the coat pigmentation gene being found on an autosome and following Mendelian inheritance patterns. I think that's it for 2.
All right, so for number 3, for A, it asks, what is the probability that the first 5 offspring have small grins and can disappear? So we did the crosses, and small grins, that would be 1 out of 4. And then can disappear, that would be 3 out of 4. So wait, hold on a sec. Okay, so okay, sorry, I did a little bit different from your screen, but I still got the same answer. Mm-hmm. So I basically just I basically just did 1/4 times 3/4, and that answer was 0.1875, and then I did 0.1875 to the 5th power, which was the final answer was 0.023%. And then for B, it's asking what is the probability that if 8 offspring are produced, 5 have large grins and can disappear, and 3 have small grins and cannot disappear. So I used the equation involving P, and I just plugged in all the numbers. So P equals 8 exclamation point over 5 exclamation point times 3 exclamation point, and then that times 9/16. And the 9/16 we got from 3/4 times 3/4. And that, so 9/16 to the 5th power times 1/16 to the 3rd power. And then 1/16 we've got from the 1/4 times 1/4. And then the final answer for that one was 0.077%. And then for C, it's asking what is the probability that an individual offspring can have a small grin and can disappear, or have a small grin and cannot disappear. So first of all, we calculate, the small grin and can disappear. So I did 1/4 times 3/4, and that was 0.1875. And then the small grin and cannot disappear was 1/4 times 1/4, and that was 0.0625. And when I added both those numbers, I got 25%. Yeah. And then for D, it's asking what's the probability that the first 4 offspring have large grins and can disappear, and the next 4 offspring have small grins and cannot disappear. So I did 3/4 times 3/4, which is 0.5625, and then 1/4 times 1/4, which is 0.0625. And then the first number I got was just 0.5625. I did that to the 4th power, and I times that number by 0.0625 to the 4th power. And the final answer is on there. It's 1.528 times 10 to the -4%.
Okay, and then Kimberly, give me 1 second. I hadn't written this out on this one, so let me just share this instead. Or no, that's the wrong one. Wait. Let me. I don't have. Where is it?
Just the instructor notes, or?
No, I have it typed out for the.
Oh,
Okay,
yeah.
there we go. Yeah, for 4. I hadn't written it out on.
Oh, okay.
There we go. Okay, can you guys see that?
Okay. Yeah. So ready?
Yes.
Okay, so for 4 for A, I said it was autosomal dominant because an affected individual always has an affected parent. And then for B, I said that it was Y-linked because more males are being affected than females. And then for C, said it was autosomal recessive because some unaffected parents had some affected offspring, and there was like equal amounts. There was no gender bias, like equal males and females were affected. And then for D, I said it was X-linked recessive because the males after the first generation were affected, and also there's like more males affected than females in general. And then for E, it was autosomal recessive because there's no gender bias, and then the unaffected parents had affected offspring as well.
Okay. And then I think I have them filled in right here, so we can just go through these. But for 5, for A, the sum probability rule is used for mutually exclusive events, while the chi-square test compares the observed outcome of a genetic cross to what was expected. B, more males are affected than females when a trait follows X-linked recessive inheritance, while an affected male produces 100% affected daughters when a trait follows X-linked dominant inheritance. C, when calculating probability, the word or indicates that one would use the sum rule. D, in probability, the term independent is used to describe events that have no influence on each other. E, when a trait follows autosomal recessive inheritance, both males and females are affected with the same frequency, and the trait can skip generations. When a trait follows Y-linked inheritance, affected fathers produce 100% affected sons. F, sampling error is high when analyzing the inheritance of traits in humans because the sample size is typically low. And G, for the purposes of the chi-square test involving genetics problems, the degrees of freedom equals the number of phenotypic classes minus 1. Okay, and I think that's everything.
Yeah.
All right. Cool.
Okay, sounds good. We'll see you guys next week then.
All right. Bye.
Bye.
Bye.